Okay, welcome everyone to the first session of the image editing tutorials. Today I'm going to be going over some basic concepts, specifically the difference between two different types of images, raster images and vector images. So what are vector images? So vectors, or scalable vector graphics, are images that are made up by a collection of anchored dots, and those dots are connected by lines and curves. So these images are not based on pixels, and the advantage that this provides is that it makes these pictures infinitely scalable. So that means you can generate images of any size and you don't have any loss of quality. So your lines are always sharp. You don't lose any of the detail of the image, no matter what size you work with. And because it's sort of based in mathematical formulae of the angles between the different dots, this keeps the file size relatively small because it just has to remember the information surrounding those dots and the lines that join them. And it doesn't have to remember an entire array of pixels. So if you look to the right here, we have an example of this. We have the letter A, and you can sort of see how the shape is made up. It's very much like a connect the dots type system of these lines between these anchored points. The software that I'll be going through to work with vectors is called Inkscape. It's a free version of Adobe Illustrator or CorelDRAW, but it's completely free and it's extremely powerful. There's quite a lot you can do with it. Then the other type of image that we have is rasters, and rasters will probably be the images that most people are acquainted with because they make up the things we interact with most on a daily basis. They're produced through pixels, and each pixel has color and tone, and that is being used to then produce the image. So the analogy here is squares on graph paper. And because the image is created with a set number of pixels, the number of pixels within the image will determine its quality. So the more pixels you have, the better the quality. But obviously this means that the file needs to store more information because it needs to remember the color and tone information for each pixel. And so this creates larger file size. And because you are constricted to a set number of pixels, this means the image can only be scaled a certain amount before you start losing quality. So if you have a look at the example of the letter A on the right hand side here, you can see how it's made up of these dots, and you can see because it's been scaled up, the quality sort of reduced. But if you squint your eyes, you can sort of see that it becomes a clearer shape. So that's a raster image, and this is probably what most people are acquainted with. The software that I'll be going over to edit rasters is GIMP, a general image manipulation program. But there are other powerful alternatives such as Krita, but Krita is more for people who are wanting to do sort of digital painting and art. It leans towards digital art more than just general image editing, whereas GIMP is basically free Photoshop. But most of you will have worked in Microsoft Paint. If you've got the new Paint 3D, that's also a free software that you can use to edit raster images. So there's quite a lot of options. So yeah, I won't be going over anything in Krita. I'm just putting it out there for if anyone wants to sort of scratch the itch of digital artwork. Krita is a very, very powerful resource for that. But we'll just be working with GIMP for now. So just a little summary of vector and raster images. So again, the main difference we're dealing with here is scalability, and that's going to sort of define the utility of the different image types. So you can see here under usages for vectors, everything from fonts to logos, coin designs, laser engraving, t-shirts, patches, digital printing, lower thirds videos, so like video captions and overlays, 2D or 3D computer animation, things like that. And then raster images is photography and print materials. The file formats, vector images is quite limited, EPS, SVG, and Adobe Illustrator. I'll be working with SVGs exclusively for Inkscape. For raster images is quite a variety. So you have bitmaps, you have GIFs, you have JPEGs, PNGs, and TIFFs. People who do a lot of photography might be quite familiar with TIFFs. TIFFs are very large size, large quality image files. And then most people will obviously be very acquainted with JPEGs. PNG file formats are generally associated with better quality images. They work very, very well for images with like clean lines, images with text. So an image like this table that you're seeing now would be well suited to a PNG format. And then JPEGs are well suited to like full color photographs and those kinds of things. GIFs are animated, but that you can have a GIF that is a single frame still image. And then you also have bitmaps. Bitmaps are also very high quality images, but their file size tends to be very, very high. And the file type is not as compatible as JPEGs and PNGs tend to be. So for the training I'm going to be going through with the two softwares. For vectors, we'll be working with SVGs, and for rasters, I'll be working with JPEGs and PNGs. But the concepts and the training and that will apply to pretty much all the file formats. And then, as I mentioned, the software, so vectors is normally Adobe Illustrator. That's like the big paid software that people will work with. CorelDRAW, and then raster-based images will be Adobe Photoshop, Microsoft Paint, and then your digital cameras work with raster images, scanners work with raster images. So what relevance do these file types have to the type of work that we do, you might be wondering. So for vector work, the relevance it has would be for things like scientific illustrations. We don't really do much of that, but you never know when that could crop up again one day. One really useful thing I've used Inkscape for is graph editing and customizing. So obviously, when you're generating a graph, you will have complete control over what the graph will look like. But sometimes you might get a graph that you have access to where you don't have the raw data, or you want to make some aesthetic changes, or as in the example down below, which is going to be one of the worked examples I go through, you have multiple graphs that you don't have the source data for, and you just sort of want to combine them together. So that's a very, very useful thing. It's also, for me, I've found that editing graphs in Inkscape can sometimes be a lot faster. So for example, during my MSc, I had some graphs, and there were some very specific sort of aesthetic changes I wanted to make. And I was generating all my graphs in R, and to find the code that I needed and get it to work the way that I wanted was very, very time consuming, and I was hitting a lot of like difficulty with that. And it ended up being a lot quicker and a lot easier to just open my graphs in Inkscape and make the changes I wanted to there. Another function is map editing. So again, when you're generating maps in GIS software, the relevance here sort of falls away, but sometimes the software might just, the type of thing you want to do might just be very, very time consuming, and it honestly might just be easier to open up the image in an image editing software and make the adjustments manually. So for example, again, this is all stuff that I picked up during my studies. So this is an example also from my MSc. I've got a distribution map here, but I didn't actually have full-on distribution data to generate a proper shapefile in GIS software of the distribution. It was sort of just a guesstimated distribution based on sort of the furthest reaches of known sampling. And then simple illustrations. So if you want to make some sort of illustration just for aesthetics, so I've got an example of a flower that I drew again for my MSc. This is the type of illustration you can create in Inkscape. This is very basic. Again, as I put in my disclaimer when I started with this training, I'm not a qualified graphic designer. If you gave someone with a graphic design qualification Inkscape, they could probably make something far better looking than what I've created. But I think for the utility of sort of scientific documents and just sort of getting a fundamental point across, I think these very basic types of things work very well. And the diagram down at the bottom is the diagram created for the Nepal project. It's going to be one of the worked examples I'll go through later on, where there was an illustration, a diagram that I found online, but I couldn't find a very high-res copy of it. And I also wanted to make some changes to it. And so I basically recreated it in Inkscape and made my edits and made my changes. Quite a long way around of going to things, but depending on what you want to do and how much control you want to have over things, it's very, very useful. And again, it's just a very, very powerful skill to have in your back pocket. Then where raster work might become applicable is basically just being able to Photoshop a picture. So obviously Photoshop is a brand, but it's one of those terms that just, becomes synonymous with image editing. The picture will be Photoshopped. So cropping, resizing, adjusting color and contrast and exposure, correcting errors. So for example, there's a photo of a glacial lake from Nepal, and there were people in the photo, and maybe you don't want people in your photo, so then you just Photoshop them out. That's something that you can do in GIMP. It's really quite easy to do. Color correction, all that kind of stuff. Sharpening, blurry images, quite useful to have. Another example down at the bottom here is one of the worked examples I'll go through is where we have a map that was not generated in-house. It was sent to us, and they'd used an alternative name for a lake, and we just did not want to have the caption explaining that we have these alternative names, because that's just going to open a whole can of worms that could confuse a reader and just really be problematic. But obviously we didn't have the shape files or the source files to generate this map and correct it, and time was of the essence. So open it up in GIMP, 10 minutes of Photoshop work, and the image was corrected, and simple stuff like that. Raster image editing would also be something that you'd use for the sort of like C4 rosette type thing. So this is the Dominica example. This is something that you would generate in GIMP. And then image plates, that's the other main point. So top right there, that's an image plate where you have like multiple images arranged in a set sort of space. Some of you might be thinking, oh, but you can sort of do this in software like Microsoft Word or Microsoft PowerPoint. You can crop the images and then arrange them together. And that is a very powerful tool and very useful to be able to do. But at the same time, it leads to potential changes if the document formatting needs to be changed, if things need to be resized or moved around. It just creates a lot more admin. So depending on how much work is still to be done on the document and who is still going to be handling it, it might be better to generate a set image plate like this that can't be manipulated, just to avoid remove more avenues for error to creep into the document. So these are just some examples. Obviously, there's quite a lot of further possibility, but just for the more work relevant stuff of what you can do with the software, these are just some of the examples. So now we're going to go over some sort of very fundamental concepts that are going to come up a lot. And the first one is resolution. So resolution obviously specifically applies to raster images, but it's also something you need to keep in mind when working with vectors, because when you generate a vector image like an SVG, you cannot just copy and paste an SVG file into like a Word document. So if you've created an image, You can't just copy and paste that into Word like you would with like a JPEG. You have to export your SVG as a raster image. So you have to decide, okay, I've created this graph or this diagram. Now you need to export that as a JPEG or a PNG. And so you need to understand resolution so that you know at what size to export it. Because like I said earlier, rasters are infinitely scalable. So you can export that document at a resolution of 10,000 by 10,000 pixels and probably crash your computer in the process. But you can do that. You can have this really, really high resolution image, but that's not really necessary. So sort of having an understanding of resolution and how it comes into play with things is quite important. So a definition of resolution is the number of pixels within a raster image, and it's usually presented as width by height. So anyone who's ever been on the market for a TV will know about HD resolution, and that is defined by the height. So that's 1080. So you'll see TVs being advertised with HD resolution, 1080p. 1080 is the number of pixels of the height of the TV screen. And then 1920 is the associated pixels that go across the width of it. And so that's just an example of like a preset standard unit of measurement. A lot of computer screens will also have like HD screens at this resolution. So that means that there's literally 1080 pixels or rows of pixels along the screen. Normally, the higher the resolution, the higher the quality of the image. That's pretty standard. You can sort of see down at the bottom here, you have a 1 pixel by 1 pixel image. It's just a single color. There's only so much information that can be stored there. And then as you move across to a 100 by 100 pixel image, the quality gradually increases. So it's about finding that balance of needing to have good enough quality for your image without like overinflating your file size unnecessarily. But we'll go into that in further detail in the GIMP training. So, and also resolution becomes important when you're sort of thinking about, well, what is the purpose of this image? So for digital displays, resolution normally doesn't need to be too high, which is mostly what we work with. We've got images pasted into documents that will only really be worked with digitally. We're not printing posters or high quality photo books or anything like that. So for our means, we normally don't have to have really, really high resolution images because most of what we deal with is digital. And people can zoom in on the documents and all that kind of stuff. So that's quite useful. We don't have to deal with very high file size images. But for printing, if a document needs to be printed, you normally need to worry about the resolution, which is then reported in pixels per inch or dots per inch. So it works in the same concept. The higher your PPI or DPI, the higher the quality. The standard for high quality printing is 300 DPI, but when you're working with digital images, the default is normally 72 DPI. So if you're working on an image that needs to be printed, you need to be mindful of adjusting the DPI of the image so that you can print it in very high quality. And then you might be familiar with megapixels. Every cell phone that gets advertised, they try and pump as many megapixels into the camera as possible. And so cameras normally will deal with megapixels, which is 1,000,000 pixels. But that doesn't really come to play in our work very much. But it's just good to know that a megapixel is 1,000,000 pixels. So another concept that's going to come up quite a lot is transparency. It's also referred to as the alpha channel of an image. So the alpha channel is a color component that represents the degree of transparency or opacity of a color. So digital displays are normally made up of 3 colors: RGB, red, green, and blue. And by adjusting the amount of red, the amount of green, and the amount of blue, you can create all the different displayed colors that you see on a digital screen. If you set the green value high and you set the red and the blue low, you get a green pixel and so on. And so, yeah, understanding that each pixel has a red value, a green value, and a blue value. And then it also can have an alpha value, which is sort of its level of opacity. And so if you set that to 0, then it will be completely transparent. And if you set that to 100, it will be completely opaque. So you can see the sunflower here is probably set to about 50% transparency. So it's sort of like half visible. And in all the software, transparency is normally represented by this gray checkerboard pattern. So if we look at this example with the tree, all the gray checkerboarding around it represents pixels that have a 0 value. So if you were to like sort of cut it out, the black coloring in the picture next to it would be non-existent sort of image. The best way to sort of think of it is like old overhead projectors that were used in schools and sometimes universities. It's like a piece of plastic, a sheet of plastic that's completely transparent, and then you can sort of write on it, and only what is written with ink sort of shows through. So that's basically where the sort of concept, the best sort of analogy for it. And then linked to that is this concept of layers. So going back to the overhead projector from high school, they function like transparent sheets of paper stacked on top of each other. So most image editing, you will work with multiple layers in an image, and each layer will have a different component of your image, or different elements, and you'll separate them out. And then when you combine them all together, they all sort of get squished flat to make the final image. And you need your image to have the alpha channel to allow them to stack, because if you don't have that alpha channel, you don't have any transparency, and you will only be able to see what is in the layer on the top. You need to be able to have transparency to be able to see the layers below. And then finally, when dealing with vectors, you're going to be dealing with things called nodes and handles. So going back to that sort of connect the dots system, a node is going to be the dot, and the handles are going to be the things you sort of use to control the dots. So your nodes are sort of these anchored points. They never move around. Well, that you can move them, but generally they sort of stay in place to define the shape. And then you can have sharp nodes that have these really strong angles, and you can have smooth nodes that have softer angles. And then the lines between the nodes form the outline of the shape. And the handles then visually represent the angle and length of the lines, but they're also what you use to manipulate the shapes. So if you have a look on the right hand side here, we have a square that has sort of been edited, a yellow square, and you can see you have these sort of sharp angles between the top two nodes, and then you have these sort of softer, more bent angles between the others, and you can see the blue handles with their little like control dots. The dots are literally the thing that you just sort of click on to drag them around and adjust them. So when we're working with vector images, this is basically the sort of interface that you deal with to make most of the editing, to make most of the changes that will be done to the vector image. And that is going to be where I wrap this sort of introductory tutorial up. I will follow this up with some more in-depth things on GIMP and Inkscape with some worked examples for sort of specific tasks that I think will be useful for people in sort of day-to-day work.